Okay, so these are continuing the multi-step equations deal. And what's different here is you have variables on each side. Now you can do these so many different ways as you go to solve them. But my tip is going to be try to avoid having negatives in front of variables. And once we do one, I think that'll be more clear. So that says avoid negative, but you know what I mean, avoid negatives. So in this first one, I'm going to rewrite this, but you don't have to. And the reason I'm rewriting it is to give myself more room. But I also want you to be able to see that the left side has negative 2 plus 10p, while the right side has 8p minus 1. So this means that there are variables on both sides. So in order, I like to address the variables first. And the same way as before, like, well, if 10b is over here, I can't solve for p until I get all the the variables with p on the same side. So let's see what happens if I were to subtract 10p below here. I write it below 10p, but I would also write it below this 10p over this 8p over here. Well, this would drop out, but 8 minus 10 would give me a negative 2p. If you kept going with it this way, it wouldn't be a problem. What it would mean is that you'd later have to divide by a negative, and often that's just a little bit more work. So that is the way that works, but I'm going to discourage you to do it. Now, if you get to that step, I'd say finish the problem because you're already there. So I see 8p on the right side. I'm going to subtract 8p from here, and I'm going to subtract 8p from the left side as well. I look at my original equation. Well, negative 2 was here, so I will rewrite negative 2 on the left side, but then 10p minus 8p becomes a positive 2p. So negative 2 plus 2p. Bring my equal sign down. Well, I chose to subtract 8p because that would go away. And I see a minus sign in front of my 1, so I'm going to write negative 1 on the right side. On the left side, p is still not by itself. It has a constant with it, just a regular number. So let's take minus 2 and add 2 to both sides, so that now we're getting closer and closer and closer to having the variable all by itself. Now let me hammer home what I'm saying there. Here we had 1, 2, 3, 4 terms, and then 2 of those 4 terms had variables. So we went from 4 terms to 3 terms in our first step, and now we've gone from 3 terms to 2 separate terms, and now p is almost by itself on one side. Well, 2p is not solved, so I'll have to divide by 2 on the left, divide by 2 on the right, and p will be equal to 1/2, which I can then write slashed like that. Okay, now the check is way more involved. So now I'm going to plug 1/2 back in. Negative 2 plus 10. If you wanted to put this in parentheses, you can. I'll just write times 1/2 is equal to 8 times 1/2 minus 1. Now, the more and more you do this, you end up just doing this in your head, or maybe in your calculators you check these. So I'm going to write negative 2. Well, 10 over 2 becomes 5. So negative 2 plus 5. Well, half of 8 is 4. And so now I have 4 minus 1. Negative 2 plus 5 is 3. 4 minus 1 is 3. I was just about to start solving this. You could probably do this one on your own. I'm going to rewrite it. You don't have to. 3w plus 2 equals 7w. Just like before, well, I could subtract 7w, and if I did, everything would be fine. No one would yell at me and scold me. By the way, I do want you to see this. Do you see how that becomes 0 on the right side? You'd have to write 0 there because there's no other term that you would rewrite. But you'd have that negative there, and you just keep on solving it. You'd get the same exact result doing it my way. But, like I said, it's nice to avoid negatives. So I will subtract 3w from both sides, which leaves me with 2 equals 4w. Divide both sides by 4. Whoops. And then w is equal to 2/4, which you can totally simplify in this step and get 1/2. Let's check it. 3 times 1/2 plus 2 equals 7. And not w, don't forget you have to plug it in all spots. So 7 times 1/2. That means that this becomes 3 over 2. And if you want, you're going to have to combine these later. So let's turn the number 2 into 4 over 2 is equal to 7 over 2. Sorry, I'm having a hard time with this angle on this iPad. And then when I put those together, I get 7/2 is equal to 7/2. Cool, that checks out. I want to show you another misconception or a small area where you can make a little bit of an error. So I'm going to call this a dead end question mark. Because it's really not a dead end, it's just kind of, it ends up being like a problem that stops people. Let's say somebody ended up doing -2 first. Well, the only thing that remains on the left is 3w, and that would be equal to 7w minus 2. So on the left side, originally, we had, a algebraic variable deal. So we got something with a variable. We have a number equal to a variable. And we end up with a variable equal to a variable and a number. So it's not like anything has really been accomplished in this step if you were to do that first. So, it's not really a dead end, but sometimes it makes somebody go, well, what do I do next? Well, it didn't get you any closer to being finished with the problem. So if that happens, don't let it be a dead end. Keep going or erase it and make sure that you're combining things. So subtract 3w instead. We could probably consider this third one to be a challenge problem. And I'm going to write the words kill the fractions. So if you want to kill the fractions, let's think about least common multiple after I rewrite this. On one side I have x over 2. I'm going to write this large just because it's going to help me. X over 2 plus 1 over... No, I'm not going to write this large. I'm going to zoom in. Okay. X plus, dang it, x over 2 plus 1 equals 1 over 4x minus 6. I'm tempted to multiply by 2 because that would go away. Well, I wouldn't just be able to multiply that by 2. I'd have to also double this because it's a separate term. And I'd have to double this. And I'd have to double this. But would this get rid of my left fraction? Absolutely. Would it get rid of my right fraction? It wouldn't. I'd still have a number in the denominator. So the goal is to look for the least common multiple of those denominators. So here's 2. Well, 2 you can turn into 2, 4, 6, 8, 10, and so on. That should be a comma. And 4 you should turn into 4, 8, 16, and so on. So if I were to choose the least common multiple of 4, I know that that would get rid of all my fractions. So here's a parentheses. Here's a parentheses. Here's times 4. So now I have 4x over 2 plus 4 times 1, which is 4, is equal to 4 over 4, which I'm not going to bother writing out. I'm just going to write x. And then be careful not to just write minus 6, because you know that everything is getting multiplied by 4, so that 6 has to become 24 as well. Normally I wouldn't show this 4 over 2 as a step. I would have just jumped into writing 2. But because I did, as we're learning a new idea, I'm going to rewrite the whole thing with 2x plus 4 equals x minus 24. I would call that simplifying. When you simplify a step, don't solve the algebra at the same time. It takes more time to just rewrite it, but just do it anyway. Okay, let's subtract x from both sides. 2x minus x becomes x. I just rewrite plus 4 equals negative 24. Moving on, subtract 4 from both sides, and get x is negative 28. I'm going to scroll up just so you can see all the work, even though you have it written. Okay, so to get rid of all the fractions, we quadrupled everything, which really we ended up distributing to all 4 terms in there. In doing so, we ended up changing it from a problem with fractions to a problem without fractions. Without the fractions, that meant I would have been able to avoid having to find common denominators and do all sorts of things like that. Or maybe had something where it was like going to be 1 minus a fourth, which would be a 3/4. But I'm running out of space to write my check, so make sure that you know that what I'm about to do would really be on the right side of your page. So I remember that it was negative 28. Now we're going to plug that in like it's our check. So on the right side of your page, in that same first line you had, here's negative 28 over 2 plus 1 equals 1/4 times negative 28 minus 6. Negative 14 plus 1 equals negative 7 minus 6. Negative 13 equals negative 13. Check. Just to revisit what we went through in all these problems, solving with variables on both sides, the goal is to avoid negatives. I showed you some of the less perfect ways of doing those. And then lastly, something with fractions. And in my opinion, it's way easier to eliminate those fractions than to have to subtract 1/4 x from both sides.